Welcome back. We're in 59b, the color of the White House, and I know that was kind of a teaser. That's literally the name of section B of lesson 59. And basically the book says the color of the White House is white, and the color of the Red House is red. And the below expressions or equations can be understood just as easily. And that's all it has to do with the color of the White House. So it was a little bit misleading with the title. But basically, it is teaching us how to read these expressions and how to understand that this truly is an exponent. And so it tells us that we would read this statement as 5 raised to the power that 5 must be raised to in order to get 14. So the answer is 14. And that's literally all it is. This one would be read y raised to the exponent that y must be raised to in order to get 5x squared. That's equal to 5x squared. And then this one would be read 17 raised to the exponent that 17 must be raised to in order to get 6 is 6. So it's very straightforward. Basically, the answer is just whatever this is here, as long as the bases match one another. And that is the key factor. If these bases match, then you can cancel them out. And the answer is whatever this is right here. So let's try a practice problem. 59.4. says 42 raised to the power that 42 needs to be raised to in order to give us 5. The answer is 5. It's really that easy. So let's try another one. All right, 59.5 is a little bit trickier because we do not have the same base. So what we need to do is rewrite it with the same base. And we know that 9 can have a base of 3 if we give it an exponent of 2. So we would rewrite that as 3 to the second power with a log of 3 gives us 5. Or 3 squared raised to the power that it must be raised is 5. So what we do for this problem is we cancel out the bases that are the same. This moves to our answer. So the answer is 5 squared, which we know is 25. And that's how you would solve a problem like that. Let's look at one more. All right, now we have 10 raised to the exponent that it must be raised to times 4 gives us a square root of, or the square root of 3. So we would solve that problem by first rewriting this as a term or a base term with an exponential exponent. So we would rewrite that as 10 4 log 10, and this would become 3 1/2. So now we can manipulate that just a little bit. So the next step would be to get rid of this coefficient here and turn it into an exponent on our 3 1/2, just like we did for the 5 up here. That's what we're going to do with this here. We're going to be able to cancel these two out. So we cancel this, but then this becomes 3 1/2 to the 4th power. So we would put parentheses around it and take it to the 4th power. And then we would multiply, right? So 4 times 1 is 4 divided by 2. So that would be equal to 3 squared, which would be equal to 9. All right, let's try one more. So this one we have to remember the product rule of logs, and we are going to multiply this log times this log. So what we end up with is 3 log that 3 that is raised to the power that 3 must be raised to get 20. These two cancel, so the answer is going to be 20. All right. Once we can learn how to apply all of the log rules that we know, in this case it was the product rule, then we can apply the logic of the bases canceling one another to find our answer fairly easily. Let's try one more. So for this one, the power that e must be raised to get the E14 is going to be 14. Essentially, these two bases are the same, so they cancel. And 14 is your answer. Let's do one final problem. So this problem takes us all the way back to the very beginning. This is like one that we would have solved to start with when we first began doing these logarithm problems. We know that in order for it to have the same base, that we would have to give this an exponent of 2. So we would rewrite that as the log of 5 is that would give us 25 is 5 to the second power. So the bases would cancel and our answer is going to be 2. And that is the end of lesson 59. If you have any questions, go back through, take really good notes. You need to have every one of these example problems written out. So when you come across that type of problem, all you have to do is look it up in your notes and mimic the steps of what you see. All right, that's all we have for lesson 59. I will see you in lesson 60.